So we're just doing the last two questions of the C3 2017 paper. Question 8 is it's an exponential function with some differentiation of it. The first bit is just to find, we've given a function of the number of rabbits on an island, and to find how many were introduced, in other words when t equals 0. We can save ourselves a bit of time here by knowing that e to the power 0 is equal to 1. So p, this bit would be equal to 1. So that's 100 on the top, over 1 plus 3 times 1, plus 40, which is equal to 65. One of those cases where actually not using a calculator is quicker. Anyway, so that's the first bit. Then the second bit involves differentiating. Let's just get a bit of space for this. We've got our function and we need to differentiate it. First of all, the 40 differentiates to 0, so we don't need to worry about that bit. So it's just this bit that we need to look at. So let's let u be equal to the top bit. We're going to use the quotient rule, e to the minus 0.1t, and v be equal to the bottom bit, which is 1 plus 3 e to the minus 0.9t. Right, so we need to use the quotient rule. Quotient rule is that dp by dt is equal to u dv by dt minus v du by dt over v squared. The quotient rule is what we're going to use. So we need to work out du by dt. Well, basically we should know basic differentiation of exponential functions. E to the kx, it's a very special case of the chain rule, is e to the ekx. So that differentiates to 100 times minus 0.1 e to the minus 0.1t. Might as well simplify that now, which is minus 10 e to the minus 0.1t. And then this bit here, dv by dt, obviously the 1 differentiates to 0. So we have 3 times minus 0.9 e to the minus 0.9t. And simplify that as well. I'll just multiply it out. So then we're going to use this quotient rule thing that I've just written. So that gives us dp by dt is equal to u dv by dt. So that's that times that. So we're doing the final two questions of June 2017 C3. Question 8 is a differentiation question, and we have an equation for the number of rabbits on a particular island there. Now the first bit is to find what the number is when we're introduced. Well, it's basically when t equals 0. So when t equals to 0, we've got p. Now let's save ourselves the time by not using a calculator here. E to the 0 is equal to 1. So that's 100 times e to the 0, which is 1, plus 1 plus 3 e to the 0, which is 1, plus 40. So that comes to 65. So that's one of the cases where a calculator is slower than actually do it in your head. And then part B is just to differentiate that. Now first of all, the 40 goes to nothing, and we're going to use the quotient rule here, which I'll quote now. dy by dx, I know we've got p's and t's here, but this is how we would state the quotient rule in general, is equal to v du by dx, take away u dv by dx, all over v squared. So let's let u be equal to the top bit. That's 100 e to the minus 0.1t, and v be equal to the bottom bit, which is 1 plus 3 e to the minus 0.9t. So we can say that du by dt, differentiating that, well, let's just get one thing clear, that e to the kx differentiated is k e to the kx. It's a very special case of the chain rule. We're basically differentiating the kx to get k. So here we've got 100 times minus 0.1 e to the minus 0.1t. And that's minus 10 e to the minus 0.1t. And then dv by dt, obviously the 1 differentiates to 0, so that's 3 times minus 0.9 e to the minus 0.9t. So that equals to minus 2.7 e to the minus 0.9t. Okay, so we could now use the quotient rule. dp by dt is equal to v times du by dt, so that's 1 plus 3 e to the minus 0.9t times by minus 10 e to the minus 0.1t. Take away, and then we've got the u, which is 100 e to the minus 0.1t times by what dv by dt is differentiated is minus 0.27 e to the minus 0.9t, all over v squared. So that's 1 plus 3 e to the minus 0.9t squared. Okay, now that's actually enough to get full marks for part B, but I'm going to simplify it now, because if we look forward to the next part, it actually starts to talk about a maximum value anyway, so we're going to be equating this to 0, which means simplifying this anyway, so I'm going to do that now because I think it's a good idea to tidy things up a bit anyway. So that's multiplying that out, that's minus 10 e to the minus 0.1t minus 30. Now multiplying these two bits out, that's e to the minus 0.9t times e to the minus 0.1t, so that's e to the minus t. And here we've got the two negatives, so that's plus 100 times 2.7, so that's 270. And again, this is e to the minus 0.1t, not 0.1, e to the minus t. Absolutely no point in multiplying at the bottom. It is not simpler, probably the opposite, surely a waste of time. And then that equals to minus 10 e to the minus 0.1t plus 240 e to the minus t all over 1 plus 3 e to the minus 0.9t squared. Okay, so let's have a look at part C, as we've mentioned it already. That is basically to equate dp by dt to be equal to 0, because it's a maximum. Okay, so dp by dt is equal to 0, so that gives us that this is equal to 0. I'm probably not going to But if this is equal to 0, the bottom doesn't matter because it's the top that actually is going to be equal to 0 if the whole thing is 0. If you look at it, 0 divided by anything is equal to 0. So for a quotient to be equal to 0, we need the top bit to be equal to 0. So the bottom bit is irrelevant, except that it can't be itself 0, which it can't be here because it's been squared. So we've got to solve that. Okay, well, divide that through by 10 and take to that's going to be e to the minus 0.1t negative plus 24 e to the minus t equals 0. Times through by e to the t, you're going to get minus e to the 0.9t plus 24 equals to 0. It gives us e to the 0.9t equals 24. That gives me t is equal to ln 24. 0.9t is equal to ln 24. So t is equal to, because that's 9 over 10, 10 over 9 ln 24. They accepted the exact answer, but probably a good idea to work out what that is. And that is equal to, come to think of it, it did ask for 2 decimal places, so we really should work it out. So it's 3.53. If we then put this answer, but put the exact answer in to the original equation here, put 3.53, but the exact value of that, and just take care, we will get P equals to 102. Okay, so that's part C done. Now there's another 1 mark question for part D, which basically says for t greater than t, the number of rabbits decreases. So if we look at the original graph, it's just looking at this part here, and it says it never reaches a certain value. Okay, it never goes below, sorry, it never goes below a certain value. Which are calling k, so this is the value k, so it basically wants us to find the value of k here, which it never reaches, but it's the asymptote there. Well, as one thing we should know, that if e is negative kt, tends towards 0 as t gets larger, tends towards infinity. So basically this bit will be 0 because we just got 0 at the top. So it doesn't matter what the bottom is, because again that would be 0 divided by 1, but it doesn't matter because this top bit is 0. So p tends towards 40 as t tends to get larger, so that must mean the value of k that which is basically asking for is equal to 40. Okay, so that's question 8 done. Now we can go on to question 9. Okay, question 9's trig. There hasn't been that much trig on this paper so far, so it's not surprising. So final question. First is an identity. I don't think it matters too much which side we start off with here. It's perfectly possible to solve either way. Notice we've got 2 x's and x's and 2 x's on the other side as well. I might be inclined to use the double angle formula here. So let's start with the left hand side here. As I say, it's perfectly possible to use the right hand side as well. I'm going to use the double angle formula for sine 2x and express sine x in terms tan x in terms of sin x and cos x. Now if I put over a common denominator, that gives me 2 sin x cos squared x. Take away sin x over cos x. I basically times this by cos x on top and bottom. I put over a common denominator. Now if I factorise the top, now if you're well practiced with this now, you'll see that I've got that 2 cos squared x minus 1 is equal to cos 2x, and we've got one eye on what we're actually trying to head for anyway. So we've got the sin x over cos x that we want, times by the 2 cos squared x minus 1. Now, as I say, if you're well practiced, you can kind of recognise the trig formulas backwards. Cos 2x is equal to cos squared x minus sin squared x, but it's also equal to 2 cos squared x minus 1. It's also equal to 1 minus 2 sin squared x, but this is the one we want, so that's done. Tan x cos 2x, and that's the right hand side. And it would have been perfectly possible to start here and go in backwards to go in this direction. No easier or harder, I don't think, in my view, although some of you might find it easy that way. Okay, so that's the first part done. Then it's got an equation, and notice we've got sin x here, sin x 2x minus tan x is equal to 3 tan x sin x. So that means that I can replace the sin 2x minus tan 2x with tan x cos 2x. Now, it's fine to cancel a tan x if you like here, but the thing you've got to realise is that you're losing the solution that x is equal to 0, or indeed x is equal to 180. In other words, when tan x equals to 0. If you look at this equation, 0 is an obvious answer. Sin 0 is 0, tan 0 is 0, so therefore these are 0. So obviously 0 is a solution. So quite a number of students have missed that out by cancelling the tan x and not appreciating that that itself is a solution. I tend to like to present it like this, factorised form. Cos 2x taken away minus 3 tan x sin x equals to 0. So that gives me a tan x cos 2x take away 3 sin x equals to 0. So that basically means that we've got two things that we need to solve. Tan x equals to 0, which I say should be easy to solve. That's 0, 180, not 360 because that's not in our range. But then we have to solve cos 2x take away 3 sin x equals 0. Well, we really want to express this in terms of sine squared here. So cos 2x, as I mentioned before, one of the versions of the cos 2x is 1 minus 2 sine squared 2x. Sine squared x, sorry, sine squared 2x. Take away 3 sine x equals 0. So that gives me 2 sine squared x plus 3 sine x minus 1 equals to 0. Putting that into the quadratic formula, I get sine x is equal to minus b, so it's minus 3 plus or minus the square root of, and I think the minus one's not going to work, of course, b squared, so that's 3 squared, minus 4 times 2 times minus 1, all over 4. So that makes that minus 3 plus or minus the square root of, that's 9 plus 8, which is 17 over 4. And I think if you do take the negative one there, it gets too small, so that's no good. So we're actually only dealing with the positive one. Let's just make that clear here. Negative one doesn't apply. Don't need to write that in your work, but I'm just saying that negative solution doesn't apply here. So we have to work this. So we have we're just basically solving this equation now. So let's work out the inverse sine of that. So when I inverse sine this, I get my principal value to 1 decimal place is 16.3 degrees. But with the sine, we need to go between 0 and 180 or 0 and 360. With the sine, there will be one solution which is our principal value here, and there will be another one which is 180 minus our principal value here. So the other solution will be 180 minus 16.3, which is 163.7. Okay, and then we don't forget the 0. Let's write them all out in order now. 16.3, 163.7, and 180 degrees. Okay, so that's it, the whole paper done. I hope you found these videos useful. Okay, thanks, bye.